Fourier Series. Periodic signals, infinite duration signals that repeat the same pattern at every interval t called period. So yun, infinite duration siya pero nauulit siya.
Jean-Baptiste Joseph Fourier, a, a, a French mathematician and physicist, was the first to suggest that any periodic function can be represented as a sum of sinusoids. Kitang-kita naman natin na ang sa kanya pinangalan kasi siya yung founder ng Fourier Series at Fourier Transform.
Fourier analysis leads to the frequency spectrum of a continuous time signal. The frequency spectrum displays the various sinusoidal components that make up the signal.
Fourier analysis converts time domain signals into frequency domain representation that lends new insight into the nature and the properties of the signals and systems.
In the frequency domain, linear systems are described by linear algebraic equations that can be easily solved, in contrast to the time domain representation, where they are described by linear differential equations.
Ito yung pangalawang topic natin, trigonometric Fourier series. The Fourier series is a periodic signal xt. X of t is a decomposition of x of t into a DC component and an AC component that consists of an infinite series of harmonic sinusoids. A periodic function xt can be expanded as a Fourier series only if it fulfills the Dirichlet condition given as number 1. X of t should be integrable over any period. That is, the absolute value of x of t dt, the limits of t equals to 0 to t is less than infinity.
So, x of t has only a finite number of maxima and minima over any period. Xt has only a finite number of discontinuities over any period.
Yan. Meron tayong tinatawag na Fourier analysis. It is the process of determining the Fourier coefficients AO, AN, and BN. The coefficients can be determined as follows. Ito yung ating mga formula. Yung A sub n is equals to 2 over t integral of x of t cosine n omega t dt to the limits from 0 to t. Yung Bn naman, 2 over t, the integral of x of t sine n omega t dt from 0 to t. At yung A sub o, 1 over t, integral of x of t dt from 0 to t.
Yung Fourier coefficients na yan yung tumutukoy sa DC component at AC component. Yung sunod nating papakita yan. Yung kabuoang formula ng Fourier series. The Fourier series expansion. Yan, kung makikita nyo dyan, yung A sub O, yan yung DC component natin. Tapos yung A sub N tsaka B sub N, yan yung AC component. So, yung isa naka-cosine, yung isa naka-sine.
Pupunta na po tayo sa ating example. Example number 1.
Given the periodic train of pulses shown, obtain Fourier coefficients and its expansion. So, unang example, meron tayong given na piecewise function. Tapos, kinuha na rin natin yung period from 0 to 5, kaya 5. So, yan. Ang kailangan nating makuha ay ang Fourier series expansion. So, bago natin makuha yung Fourier series expansion, meron tayong tatlong components. A sub 0, A sub n, at B sub n. Kunin muna natin yung A sub O. So, 1/5 from 0 to 1, ang magnitude natin ay 10. Then from 1 to 5, ang magnitude natin ay 0. So cancel. Ang A sub O natin ay 2. Kunin naman natin yung A sub n. So 2/5. Tapos kunin natin yung may magnitude na 10. From 0 to 1, 10 cos so ano naman siya, indefinite integral naman siya, kaya pwede natin siyang i-type sa calcu at makukuha natin ay so yun, kung manual solve naman tayo, ang makukuha natin dyan 4 sin n omega t n omega from 0 to 1 negative integral ng cos negative sin, kaya negative. So nakuha na natin yung value ng A sub n, kunin naman natin yung value ng B sub n. So, substitute lang natin yung values. Then, yung may magnitude ng 10. So, mula dito, pag nag-solve tayo ng integral, makukuha natin ay 4 cosine n omega t limits from 0 to 1. So, mula dito, since 0 yung lower limit, magiging 1 siya. At makukuha natin tong sagot na to. So, yun. Meron na tayong b sub n. So, nakuha na natin yung tatlong coefficients. So, doon na, pupunta na tayo sa equation ng Fourier series expansion. So, meron tayong value ng a sub o, a sub n, tsaka b sub n. So, yung a sub o natin ay 2. Yung a sub n natin, 4 sine n omega over n omega. Tapos, yung b sub n natin, 4 1 minus cos n omega over n omega. Makukuha na natin yung equation ng Fourier series expansion. So, ito yung equation niya. X of t sub o plus so, substitute lang natin yung mga nakuha nating values. 2 plus, since common yung 4 sa kanilang dalawa, ilalabas na natin yan. So, iwan na lang ay sin n omega over n omega cosine n omega t plus sin n omega t. So, yan na yung ating Fourier series expansion.
For our example number 2, meron tayo ditong ang sawtooth signal. Para makuha natin yung Fourier series expansion, kailangan mo natin itong piecewise function na to. Para makuha yung piecewise function, kailangan natin kumuha ng isang cycle mula sa ating waveform. Para makagawa ng piecewise function, kailangan consider mo yung isang cycle na yun. Magnitude, yun yung 5, ito yun. Tapos, kaya naging negative 2.5 kasi pababa yung slope niya. Ang dyan, rise over run. Kaya siya naging 2.5. Okay. Kukunin na natin sisimulan natin isolve yung Fourier series expansion. Merong tatlong coefficients ang Fourier series expansion. May AO, may AN, at may BN. Ang sawtooth waveform ay isang odd symmetry. So ang AN coefficient niya ay 0 na. Kaya hindi na natin kailangang isolve yan. Simulan natin ng pag-solve. Ang AO, sample number 2. Find the Fourier series expansion of the backward sawtooth waveform. Of t dt with the limits of 0 to t equals 1 over 2, 0 to 2, 5 minus 2.5 t dt. Yan ay isang definite integral, kaya pwede na natin yan i-input sa ating calcu. Pag na-input na natin yan, ang makukuha natin sagot ay 2.5. Yan. Sumunod naman ay ang Bn. Ang Bn, formula niyan ay 2 over t g of t sine n omega ot. The limits of 0 to t pa rin. Input natin yung ating given. 2 over 2, 0 to 2, 5 minus 2.5 t sine n pi t. Distribute na natin yung sine n pi t para ma-integrate natin ng maayos. 5 sine n pi t minus 2.5 t sine n pi t. Yan. Integrate muna natin itong una. Ito, 1 na yan, kaya okay lang yan dyan. Ang integrate form niya is 0.5 over n pi cosine n pi t with the limits of 0 to 2. Dito naman sa pangalawa, kailangan natin gumamit ng integration by parts. Ang formula nun ay uv minus the integral of v du. U is equals to 2.5t, du equals 2.5 dt. Ang dv sine n pi t, ang v ay equals to negative 1 over pi n cosine n pi t. Input na natin yung mga values na yan sa ating formula. Magiging plus negative 2.5 over pi squared n squared sine n pi t plus 2.5 t over pi n cosine n pi t. The limits of 0 to 2. Ayan na. Ito na ating Bn. Tapos, pagka in-input natin yan sa calculator, ito 0 na, ito 0 na. Kaya 0 plus 0 plus 5 over n pi cosine 2 n pi minus 0. Simplifying 5 over n pi. Ayan. Nakuha na natin yung Bn, so kuha na natin yung pinakatanong, yung sabing Fourier Series expansion. Meron tayong formula dun. Gt is equals to AO plus summation of Bn sine n pi t with the limits of n equals to 1 to infinity. Hindi ko na sinama yung an kasi nga 0 na siya. Mag-substitute na tayo ng values. AO is equals to 2.5 plus 5 over pi summation of n equals to 1 infinity 1 over n sine n pi t. Yeah, final answer. G of